So we proceed to word problems or the application of linear equations. So in solving this type of problems, so be sure to familiarize the terms. How do we translate worded problems into algebraic equations? So for example, we have we have the number-related problems. We are just to deal with numbers. Problem number 1, our first example. So the sum of two numbers is 19. The larger number is 1 more than twice the smaller number. What are the numbers? So let us represent the unknowns into variables. Let's say x is the smaller number and y will be the larger number. According to the problem, the sum of two numbers, that is x plus y, is equal to 19. So let this be your first equation. Then second statement, the larger number is 1 more than twice the smaller number. So be familiar with the terms. So let's have the larger number of y is 1 more than twice the smaller number. So if you are to take the twice or 2 times the smaller number, you are to add 1 since it is 1 more than twice the smaller number. So we have this equation, y is equal to 2x plus 1. Okay? So we may determine the unknowns by using elimination or substitution. But for this case, I'll be doing substitution. I will substitute the equivalent of y in the first equation. So from the first equation, this is x plus, what is the equivalent of y? That is 2x plus 1 is equal to 19. So we'll be having 3x plus 1 is equal to 19. And this is 3x is equal to 19 minus 1. This is 3x is equal to 18. Dividing both sides of the equation by 3, we have the value of the smaller number. This is now equal to 6. So this is one of the answer. So the second number, all we have to do is substitute y is equal to twice of 6 plus 1. So we have y is equal to 12, 2 times 6 is 12 plus 1, this is 30. So this will be our answers. So the numbers are 6 and 13. This obviously, if you have to do the checking, so we have 6 from the first statement plus 13 is equal to 19. That is correct. That's our first example. Let's have the second example. Number 2. The denominator of a certain fraction is 3 more than twice the numerator. So if 7 is added to both terms of the fraction, the resulting fraction is 3 over 5. So find the original fraction. So let's say we have n is our numerator and d will be our denominator. Okay, so let us express every word or every sentence into algebraic equation. So we have the denominator of a certain fraction is 3 more than twice the numerator. So let's have the denominator is that is 3 more than twice the numerator. That is the same as twice the numerator, 3 more, that is plus 3. That is the equivalent of the denominator in terms of the numerator. The next statement, if 7 is added to both terms of the fraction, the resulting fraction will be 3 over 5. So we know fraction, this is n over d. If we are to add 7 on both terms, we have n plus 7 and the denominator plus 7. The resulting fraction is 3 over 5. So we are looking for the original fraction. Again, we have two equations or two unknowns. So we may do here, we may simplify the second equation by cross multiplication. That is 5n plus 5 times 7 is 35 is equal to 3 times the denominator plus 3 times 7 we have 21. So let us express this equation in terms of the numerator. That is the same as 35 minus 21. We have the denominator is equal to 5 times the numerator. 35 minus 21 is 14. This is divided by 3. So this is the equivalent of the denominator in terms of the numerator. Then we substitute this one to the first equation. So we have, from the first equation, the denominator is equal to twice the numerator plus 3. Let us substitute the equivalent of the denominator from the second equation. That is the same as 5 times the numerator plus 14. This is divided by 3 equal to twice the numerator plus 3. To eliminate the denominator, we are multiplying both sides of the equation by 3. So this is the same as 5 times the numerator plus 14 is now equal to, this is the same as 6 times n plus 9. Then transpose, we have now 5n minus 6 of n, 6n is equal to 9 less 14. So this is the same as negative n is equal to negative 5. Or we can have the value n by multiplying both sides of the equation by negative 1 or dividing both sides of the equation by negative 1, we have the value of the numerator to be 5. Okay, this is our numerator. Okay, so we can now compute for the denominator. I'll be using this equation. The denominator is equal to twice n. What is our n? We have 5 plus 3. So we have the denominator is equal to 2 times 5, that is 10 plus 3. We have this as 30. So therefore, what is our original fraction? The fraction is n over d. That is, we have 5 divided by 30. So this is our example. Okay, and that is our answer. We have 5 over 13. That is the original fraction. If you are to check, you may use any of the statement of the problem. For example, the statement that we are to add 7 on both terms and the resulting fraction is 3 over 5. Let us check. We have 5 plus 7 divided by 13 plus 7. 5 plus 7 is, 5 plus 7 is 12. This is divided by 7. 13 plus 7 is 20. So both are divisible by 4. So this is the same as 3 divided by 5, which is true. Which is correct. It will result to a fraction 3 over 5. So we proceed to a digit problem. So before we proceed with the examples, so for example, how do we present an unknown 3-digit number in terms of variable? We have, for example, this number, let's say 257. So h is the hundredths digit. We have 5 is the tens digit. Then 7 is the units digit. So how do we present 257? For example, we don't know these 3 numbers. That is the same as 100 of h plus, that is for the hundredths digit, multiplied by 10 times the tens digit plus the units digit. So again, if you are to, for example, compute for the, or to have the actual value of the 3-digit number, that is 100, what is our hundredths digit? This is 2. Plus, we have 10. The tens digit is 5 plus the units digit as it is 7. So this is the same as 200 plus, this is 50 plus 7, which is the same as 200 plus 50 plus 7 is 250 plus 7. So we may express the unknowns in terms of this terms. 100 of h plus 10t plus u if we have 3-digit number. So let's have example number 1. Example number 1. In a 2-digit number, the units digit is 3 greater than the tens digit. Find the number if it is 4 times as large as the sum of its digits. So we have, for this case, Number 1, we have a 2-digit number. So this is tens and the tens digits and the units digit. So according to the problem, the units digit is 3 greater than the tens digit. So we have the units digit is that is the tens digit 3 greater, that is the same as plus 3. So again, be familiar with the terms used. Okay, so find the number if it is 4 times as large as the sum of the digits. So how do we express the actual number? The actual number is 10 times the tens digit plus the units digit will be equal to, according to the problem, it is 4 times as large as the sum of its digits. So we have that is 4 times the sum of its digits, that is t plus u. So we can simplify this one. This is the same as 10 times t plus u is equal to 4 times t plus 4 times u. So this is the same as 10t minus 4t is 6 times t equal to 4u minus u is 3 times u. So we may divide both sides of the equation by 3. Let's have the value of u as twice the value of t. So we may substitute this one on our first equation. Okay, from the first equation, this is u is equal to t plus 3. What is the equivalent of u? That is 2t. We have 2t is equal to t plus 3. So this is the same as 2t minus t equal to 3. So the value of the tens digit is simply equal to 3. This is our tens digit. Can we now have the units digit? The units digit is u is equal to, this is u is equal to, the value of the unit of the tens digit is 3 plus 3. So we have the units digit equal to 6. So we have the actual number. The actual number tens and units is equal to, the tens digit is 3, the units digit is 6. Therefore, our 2-digit number is 36. You may check this on our on this statement. So according to the problem, is the number equal to 4 times the sum of the digits? What are the digits? That is 3 plus 6. We have 36, is it equal to 4 times 9? So obviously 36 is equal to 36. So this is our answer. The 2-digit number is 36. Alright, let's try number 2. So the hundredths digit of a 3-digit number is twice the units digit. So this means we are dealing with a 3-digit number. So let's say this is eights, hundreds, tens, and units digit. So the sum of the digits is 17. If 396 be subtracted from the number, the order of the digits will be reversed. So find the sum of the squares of the digits. So we have here, on the first statement, that is the hundredths digit of a 3-digit number is twice the units digit. So this is h equal to twice the units digit. That is be your first equation. Then we have the sum of the digits is 17. So therefore, if we are to sum up h plus t plus the units digit should be equal to 17. So another part of the solution. Then if 396 be subtracted from the number, so we should express the number that is 100 times h plus 10 times t plus the units digit. We are to subtract 396. So this is minus 396, and the result, so if 396 be subtracted from the number, the order of the digits will be reversed. So which means we have to reverse the arrangement. That is, instead of h, the first the first digit will be the u. That is 100 times u. That will be the first one. This time, since we are to do the reverse, okay, plus, since this is the middle term, it is the same as 10 times t. Then the last digit will be the hundredths digit. Okay, so we are to do the reverse. So from HTU, it will be UTH. If you have to subtract, 396. Then we can simplify. Okay, we can cancel out. I think we can remove 10t since they are on both sides of the equation. So we have 100h minus h is, this is 99 up, h. Then we have u minus 100u, that is minus 99 up u is equal to, we have to transpose 396, it will be positive 396. So I think every term is divisible by 99. So we have, this is now h minus u is now equal to, what is 396 divided by 99? We have that as 4. So we have this, our third equation. So as you can see, we have 3 unknowns. So basically we need 3 equations. So we may have, we may compute one of the unknowns. From the first equation, we have h is equal to twice of u. We may substitute this one, the value of h, to the third equation. So this is, and the third equation, h minus u is equal to 4. This equivalent of h. This is 2 times u minus u is equal to 4. So therefore, 2u minus u is u is equal to 4. So we have the units digit equal to, that's equal to 4. And then we have to compute on the hundredths digit. The hundredths digit is equal to twice of u. We have h is now equal to twice of the units digit is 4. We have the hundredths digit is equal to 8. Okay, so we have now the units digit and the hundredths digit. Lastly, we are looking for the tens digit. You may use this equation. That is h plus t plus u is equal to 70. That is from the problem. So what is h? That is 8 plus t plus the units digit is 4 is equal to 17. So we have the tens digit is equal to 17 minus 8 minus 4. That is 17 minus 12. That is equal to 5. So therefore, what is our original number? That is h t u is 854. That is our 3-digit number. 854. But we are looking for, what is the reward on this problem? Find the sum of the squares of the digits. So we have the sum of the squares, that is, we have 8 squared plus, we have 5 squared plus the units digit, this is a 4 squared. So we have the sum, so we will do, that is 64 plus 25 plus 16, that is 8 squared. So we have the answer as 100, this is 105. And this will be our answer for this example.